everybody, Brian here from quantlabs.net. Just wanted to go through the most basic message queuing possible. Let me just show you a couple things. I have on my YouTube channel, quantlabs.net, sorry, quantlabs, right here, youtube.com/quantlabs. A couple things. We have the C++ for trading, as well as we've got the Python attack, and then we also have, more importantly, Redis. So what I'm about to show you is affect these playlists, so you can always go through these at your own time. Alright, so what I'm about to show you, damn. Okay, whatever, I'll go away. Okay, so what we'll have here is, first let me show you the Xcode. This is my C++. What I'm about to show you is very basic queuing between Redis, using Redis SQL, NoSQL, as both your database in memory and your message queues. Now I just had a couple of questions regarding 0MQ. 0MQ is fine for queuing, but does not include the replication and redundancy, as well as the clustering that Redis gives you if you choose to use the Sentinel version of Redis. I'm not going to go into any further on Redis itself. There's lots of resources out there, but it's probably, out of all of them that I've seen, I always come back to it, and I've looked at a lot. Okay, the next thing, I have two, let me just show you a couple things. In here, I've got two very basic, three basic Python scripts. Now, for me, there's different design patterns that you can use with Redis. There's basically like a push of data into Redis. So when you do that, what happens is you're able to queue and retrieve that data through another language, and Redis talks to pretty well anything. And this is true open source. It's very fast. It's not going to be the fastest option that you have if you do decide to go, in my case, high-speed trading, but it's a pretty damn close, and yet, for me, convenient option. So when you have the three scripts here that I'm referring to, using publisher, subscriber, what we're doing is we have a publisher on one side, then we have a subscriber on the other. So just want to show you the basics in one of the scripts. It's for all the newbies here. They're always going to be out there. Alright, so in my Sublime here, in Python, what I'm doing is very simple. It's not even 9-10 lines. We just load in our packages that we want, connect into the Redis using the default port and all that. But here's the key. All we have to do is, once we connect into Redis with a queue, we just publish data into it. So in this case, we have a topic and our message. So the message will get interpreted as a string, and we're just going to call it topic called test. And that's it. And sleep, and then do it again 10 times. Now in my C++, it's very simple. Now, just so you know, with the Redis packages, let me just go over to the Redis here. Redis is kind of tricky. If you go to redis.io, the Redis clients are the language support for Redis. Most of the languages, I'd say all the languages are fantastic support except one, C++. Now, you have some choices here, but you gotta be really careful what you choose. The one I'm gonna show you that I've got working now, because I'm on a Mac, which can limit it even further, after many hours of pretty well experimenting all of them, the one I got to build and working was Redux. Okay, that was a while ago, about 6 months ago, and I'm sticking with this, even though this library yet again has been abandoned, and I'm hoping somebody will fork it and upgrade all the latest and greatest for Redis. And I'm hoping that happens, because it is a really good wrapper that sits on top of High Redis, which is a C connector into Redis. Okay, so I'm using Redux here for that. So knowing that, we've got a very simple thing going on. Now I'm experimenting with threads still, but because I'm breaking it down to really simple stuff, what I've done is I'm using, another one of the big struggles I had was which library to use for the threading. I'm still kind of loosey-goosey on it, But I'm gonna be honest with you. I'm gonna stick for now with the standard. And people have said, why don't you use TBB? Why don't you use OpenMP or Silk? Well, nothing wrong with any of these libraries, but there is the right reason for every application. In my case, I'm just trying to keep it simple. I will say I've used TBB, and it works great on Mac, and I'm now using, if it can compile and build out of box on my Mac, that's a pretty good accomplishment for a library in itself. So I'm going to stick with that methodology, and TBB fits that no problem because it's coming from Intel. Now the thing is that they have a tool on TBB called FlowGraph, which is in alpha for Windows, but it does have the capabilities to code generate in C++, but the code it generates is really bad. So it comes back and kind of puts you in a really bad quagmire and trying to decipher that code. No different than if you're looking at another library that I really liked, but again, I couldn't really figure it out or reverse engineer it. And so I dropped that. That was OpenHFT, which was in Java, which is got a lot of potential, but again, it's just becomes bloatware after a while if it's just a lot of extra code that you don't really need. So again, coming back to the threading, I'm just using the standard threading. I put up a book review on that in the last couple of days. So if you can, check it out. But anyways, this thread is so dick easy. It's brain dead. So I've got a function here in C++ called Redis sub. So as I said, we've got our subscribers I showed here. Okay, and then I also talked about it's a publisher subscriber pub sub. So in my case, we've got the subscriber, which I'll show you in Python so you can understand it. It's basically the same idea, but on the receiving end of the publisher, which is now the subscriber, what we have here is we have the local host, or connecting in Redis as usual, and basically subscribing to that test topic that we had in our publisher. So every time we publish something on that topic, the queue of test, it raises an event, triggers it, and will do something. In this case, it will just basically get the message and then print out that message. And that's it. That's a queue with redundancy and clustering built in. And that's one of the beautiful things about using Redis, and it's fast. And anything I've seen, it's still the most convenient. So when you come back here and you look at now the subscriber for C++, I don't really need to give out the code. It's really dead easy using the Redox wrapper I just showed you for Redis, this guy right here. So all we're doing is, as I said, we've got our thread, we join, which basically kicks off or spawns the function here called Redis sub. And all it does the same idea, connects into Redis using this, sets up a subscriber, and all we're really doing is we use auto data types in C++ and the wonderful complication of C++, but when you dig into it, you really get to use it because it brings in a lot of flexibility you don't get with other languages. So anyways, we got our auto for subscribe or unsubscribe, and these are all lambdas, as you can see right here. So I would expect you to know what these are in C++. And at the same time, we have a lambda for got message, and all we're doing is just printing it out. But what I'm going to do to keep it really primitive is really important. So you'll see here, we have our message that comes in through the got message, parses it using that topic I showed you. And when I say topic, it's kind of like an index of a table. If we look at the publish, what I'm referring to is this right here is the topic. So we're going to call it test. So on the C++ side, keeping it really dead easy is we're basically going to listen for all messages that come in on the topic of test. Okay, so in the data, what I've done is basically, if you see your messages equaling 10, it'll exit out of the loop, because this is basically equivalent of a for loop right here. So this gets all set up as usual, sets up this loop. So I've got a global Boolean variable called exit loop. We set it to false, and once we go through all the definitions and everything, we basically set the loop while exit loop is false, right? And I'll just keep looping, listening to those messages. And if we have in our data, in the message, listening to topic of test, and the message equals 10, all we gotta do is just exit, okay? So I'm gonna show you that as a demo. It's really, really basic, but I wanted to show you just the communication part between something like Python as a publisher and sending and using the C++ as a subscriber. Now, also I can set up my Java as a publisher as well, and I've got many demonstrations of that using, let's say, IP feed as an example, where I'm using IP feed from my market data, live data, coming in, and I'm pushing that into Redis as a publisher. And at the other end, we have our subscriber. So this is basically evolved over many, we'll call it a couple of years, really. And I also got the same idea using with interactive brokers as well. So if you come under the interactive brokers channel, you'll see some examples, and specifically in the Java test client that I've talked about, you will find right here that I am demonstrating how to push data into Redis as a publisher from the interactive broker side. And I also can use another queue using Redis for the orders as well. Lots of flexibility here, but this, what I'm showing you, is the glue. And I'm showing you now the C++ side as well. So I've got on my YouTube channel many demos of using Redis, pushing data back and forth between publisher and subscriber for both Python, Java, and C++ in a non-Windows environment. Okay, so basically that's how it works. So let me show you some demos. So you just load up your Redis server, and using the default port 6379, and I've shown you the publisher. Let me just show you first the Python publisher and subscriber both running at the same time. Okay, so we have Redis server running in the background. I'm going to set up my my publisher subscriber in Python, nothing but Python. Okay, so hopefully this will address a lot of questions that I've got from people this week. Okay, so here's my two scripts. We're going to deal with this and this. So first, let me set up my Python subscriber, which I just showed you. So it's subscriber 1. So now I'm going to set up my publisher right here. Oops. Okay, let me just execute that. So we've set up our publisher, our subscriber listening. So we're going to set up our publisher. There you go. So right now it's sending over the subscriber the different messages of that loop that I showed you of 0 to 10 here, right here. So it's doing a loop from 0 to 9 or 1 to 10, sending the message through to Redis, and it's just getting subscribed on the subscriber using Python. Okay, so this is basically an infinite loop, so I'll break that, exit. So now what we're going to do is I'm going to set up my C++ side in Xcode from Apple, using the exact same code I've shown you in C++, set it up. So here we are. Oh, get rid of this breakpoint. Okay, let me just have it continue. Or let me just break it and relaunch it. Okay, so now it's subscribed to that queue. Or yeah, to the queue. So what I've got here, just watch this little box here. I'll run the same publisher, but now we're pushing it through Redis again into the C++ version. So it just displayed all the same thing that you saw on the publisher, on the subscriber, Python, but now we're doing the same thing but in C++. Now, remember I said, how do we exit? Well, it's just going to sit there and listen, but as soon as it gets that message number 10, it's going to exit the loop and exit the program. So once it gets that message 10, it's going to break the loop right here. And what it'll do, it'll start unwinding everything, basically. Unsubscribing everything and disconnect from Redis, because you're telling in the data to exit the loop and then unsubscribe and disconnect from Redis and basically exit the program. Okay, so we'll run that. Well, I just ran the publisher. So what I have now, I've got another publisher called 10, and it's going to do just that. So let me just show you that. Okay, so what we've done is exact same code as before with the publisher in Python. The only difference is I bumped up that range from 1 to 10, but I've added one extra iteration. Because of that, that's going to be the 10th message. So it'll be message number 10, and I'll break the loop. That's all it does. So if I run pub 10, which I just showed you, okay, so we're still listening. So now what's going to happen is it's going to send in the messages right here. Boom. Message 10, break, unsubscribe, and disconnect from Redis. And it's terminated the program. And that's it, basic stuff. So that's the basic communication between C++ with Redis as a publisher subscriber, which is pretty powerful in itself. Now, where do we go from here? Well, in this case, really everything comes down to the message that we push or we subscribe to and interpret here. That comes down what I'll call the pipe from Redis. So here I have full control of parsing, splitting that data, that message. So if I'm going to push market data being a bunch of calculations, open, high, low, close, or whatever, run some calculations in this little lambda or other functions that get called from this lambda, we can then basically run a pile of calculations, and then right there can be a point of make decision. Do we exit that trade, exit the position, as I've gone on about for the last month. So it's very primitive, very basic, but it works, and believe me, it's probably as fast as I get. The only thing that I've been looking at when I look at all this multi-threading libraries and whatnot, the key here, and I've said it before, depends on how many algorithms you're going to be running. So in my case, let's say if I do, I don't know, pair trading is a good example, as my first example of this. I'll basically have 3 calculations to run. First is the decision to exit the trade itself based upon just market data, pure market data, nothing else, using, as I said, average true range. The other thing I'm looking at is, of course, stop losses and soft targets. I've gone on about those in other videos, but those are 2 separate calculations I'll use in conjunction with the ATR to measure the exit. Now, I can also put in additional algorithms as well, Kelly criterion to measure the trade against my real-time portfolio, where I could use that as a risk measurement or risk gauge to say, well, do we exit the trade? Is it too premature if we have a running trade? That could go profitable, so why would we cut off the profitable profitable opportunity? So we could use those kind of algorithms on the fly in real time, but that's the key here is kicking off more threads to do further calculations. But this is where it gets really tricky, is depending upon the box that you use and the competition of your computer cycles and your threads, and the algorithms themselves, are they highly optimized on each one for each calculation? So let's say if you have a set of data coming in for one asset that you're watching, you now have to kick off, let's say, 3 new threads or 3 new calculations somehow in parallel to measure that data and get a quick decision back saying yes, no, get out of that trade using that particular data set or that rolling window of data, and then exit everything. Okay, so using this queue is very easy. It's now, the tricky part now is the actual algorithms within this Lambda and the kind of algorithms and how long they take to process and da-da-da. Problem is, if you overwhelm your queue with not just one data set, like one market, like one type of security, one type of instrument, and in itself you overwhelm the processors that you have available on your system, you're going to have a real problem, because you're just going to do that. You're going to overwhelm your threads, and you're actually going to make your processors much slower than they should be. So it's really key to understand how to handle that data and to really understand the architecture of your system. The other thing you need to consider is, if you're just watching one, fine. You've now stopped your analysis. But if you have, let's say, 4 or 5, 30 different pairs that you're watching, that just further complicates exponentially what you're already needing to worry about in terms of available processors and threading. So this is really key to really understand it. And if you don't really understand it too well, you will have an application that'll crash. So this is really critical. Fully understand this. So I'm just showing you all this, but the really big advantage with this is, because you're using Redis, you can easily, because right here, in your connection, right here, you can basically control where you connect into Redis. So you can have multiple instances of Redis available, so you can set up pools. And not only that, depending upon your threading library you decide to use, that also enables you to have further threading pools. But then it comes down to a trade-off between lock, if you want something that's lock-free, or do you want to have a set of threads available in a connection pool, then you have to worry about locking those up and using semaphores and mutexes to protect the data as it comes through. And it's a lot of work, and that's where you need to really understand these steps to really to really properly implement it. Now, when it comes down to the programming languages, I've looked at Java. I can tell you Python will not give you any further advantages over this than C++. From my perspective, I think C++ is the best for doing this. And when you start using Java, you have to always worry about your garbage collection, which can really add another set of complications. But if you know how to handle your data properly, as in this case, we're properly cleaning up as we subscribe to Redis and so on and so forth, we can easily not worry about those connections. But as you advance your knowledge in your threading library, you got to ensure that you properly understand how that comes down to. Now, if you have not seen my latest videos, there's a really good book that really opened my eyes. Is this book here, C++ Currency in Action. So I've done a full 36-minute video on that. And then there's also some code that I show you how to use to, demonstrate and really understand your multi-threading in C++. Okay, so there's some other tools I've added here. NetMap with the kernel bypass, but it's another world to worry about. So I've added, over the last couple of weeks, various demonstrations with OpenHFT, a couple of the SQLite, and some of the various threading libraries and stuff. So I've done a lot of work here, and hopefully you can go through that at your own leisure. And yeah, that's about it. So, but this will definitely work in a very simplistic and a very basic level and work from that, depending upon how you build out your algorithms specifically, not just your trading algorithm, but also your risk algorithms. And if you're going to start applying, as I said, stop losses and soft targets and whatever else there may be that I can't think of. Yeah, but the key is to understand and optimally understand what's available to you and ensure that you properly test it to enable you're not going to get crashing applications when you go into a live trading environment. Hopefully this will help you out. Over and out. Later.